So here's an example of adding two vectors, and we're going to use a graphical method, the triangle method. So we have two displacements, whatever, a person and object. Delta D1 is 22 meters east, 33 degrees north, and delta D2 is 11 meters east, 28 degrees south, and we're required to find delta D total. All right, so which means we need to find the magnitude and some angle of direction. Okay, so I already have a diagram here. The only thing that I'm going to add is the actual displacement, total displacement, which it's roughly this line here. All right, so this is delta dt, right? So obviously we have this triangle here, and that's what we're going to work with. Okay, so we're pretty much going to solve an obtuse triangle using pretty much we're going to use cosine law and sine law. All right. So of course, to use we use cosine law to find first the magnitude of delta dt, which is the square root of the other two sides squared added minus twice the product of the two sides and the cosine of the angle between them, which is 119 degrees. Let me show you how I got the 119. So I'm going to extend this east-west line. So this angle here is 33 between vector delta d1 and east, which means if I look at the z pattern, so is that angle there. Right, so I'm going to put it with two lines. So if this is also 33 degrees, the other one on the right side is 28, it means that this angle here, the one I just used, is 180 minus the other two, therefore 119 degrees. All right, so if we do the math here, delta dt is roughly 28.9 meters. All right, so I'm just carrying an extra digit, but I have to report two significant digits, as you can see from the given information. The next step is to find some sort of an angle in this triangle. So what I'm going to do is I'm going to put it here. We're going to find this angle. Let's call this, I don't know, just theta. All right. And we all can see that if I find, like, ultimately I need an angle between our vector and one of the compass directions. So this angle here would be a good one. Let's call this theta t, right? And you can see that theta t is 33 degrees minus whatever we're going to find. All right, so let's first find that angle theta in the triangle. We're going to use the sine law. All right, so we have sine theta over the opposite side, which in our case is 11, is equal to sine 119 over the opposite, which is the one that we just found, 28.9. And then, of course, from here we can find theta, 11 times sine 119 over 28.9. And again, we use a calculator, and we find this angle to be roughly 19.4 degrees. So I'm going to go back here, and remember that's not our final answer. That's just one step closer to the final answer. So now we know that our angle, theta t, is actually 33 minus whatever we found, right? So theta t is approximately 13.6 degrees. All right, so now we can report our answer. So hence our final answer, delta d total, is approximately 29 meters, and the direction is, now let's look at the direction. So the angle that we found, remember, is this one here, this one. So it's east, whatever we found, then 13.6 degrees north. So now we can report it. So again, it's east 13.6. Actually, we're going to use two significant digits, so we're going to make it 14 degrees north. And here is how we find the sum of two vectors using graphical method or the triangle method. Next step is going to be the component method. So we're going to use the same vectors, and we're going to see how to use a component vector.